In this work, we built various scenarios for forecasting the COVID-19 in a country with insufficient experimentation data, by deep learning models that imitated the spreading rate of COVID-19 in other nations. We have applied this method to Vietnam, and its regional countries includes the Philippines, Malaysia, and Thailand. The nations where the Delta variant of SARS-CoV-2 has surged sooner than it has done in Vietnam. The models are constructed to be pure LSTM, GRU, and hybrids between them. Through experiments, we accredited that GRU outperforms the other models, and the hybrid models always give better performance than the pure LSTM in terms of MSE, applying to the datasets in this research.
The recent outbreak in Vietnam started on May 8, 2021, in the northern provinces. 10 days later, 2 cases of the Delta variant were detected in Ho Chi Minh City. The surge was alarming from July, when the number of new cases increased daily by 4 digits, and gradually hit the mark of 5 digits. Meanwhile, the Philippines, Malaysia, and Thailand reached 4 digits in late 2020.
The main contributions of this article are: propose a machine learning method to build multiple COVID-19 scenarios in a country where there is not enough data for experimentation. Conduct research directly to Vietnam and its regional countries in Southeast Asia where there is an unprecedented challenge with Delta strain of SARS-CoV-2. Accredit the outperforming of GRU and hybrid models in comparing with LSTM in terms of MSE on this research data.
A recurrent neural network, RNN, is known as a short-term memory, because it can capture the previous state of the process. Figure 2 shows the architecture of RNN. Long short-term memory, LSTM, is a form of RNN. It is built on a bunch of gates, including forget, input, and output. They work together to fulfill the functions of an LSTM unit and control information flow. While RNN can only capture a short-term sequence, LSTM can remember long-term one as the result of the gates. The structure of a cell in LSTM is presented in Figure 3. GRU is an improvement of LSTM. The cell state in GRU is combined into the hidden state. The gates in GRU are set to reset and update, to decide whether to store and discard the information. The basic structure of one cell in GRU is shown in Figure 4. The simpler the gate structure of GRU, the faster it can process data than LSTM, because it uses fewer parameters. If all layers in a network are LSTM or GRU, it is called a pure LSTM or GRU model. We can replace a layer in the network with a different kind of cell, in this case the model is called a hybrid one. In this study, we compute 2 hybrid models by altering the layers to be GRU LSTM or LSTM GRU, as shown in Figure 5.
We collected new COVID-19 cases by day in Vietnam, the Philippines, Malaysia, and Thailand from Johns Hopkins University Lab, from January 2020 to the end of July 2021. The data is shown in Table 1. There are 556 records, 4 data columns, and date is the index of the table. Normalize the data in Table 1 to the closed intervals 0.1-0.9 by min-max scalar. Then each country's column is extracted to univariate sequences series, with 15 learning steps in the past, and 15 steps in predicting the future. This gives 4 learning datasets, that have the same shapes as demonstrated in Table 2.
The experimental procedure has 3 steps. The first step is normalizing and extracting data from each country to make learning datasets. The second step is computing, training, and validating models. We use data in Vietnam for the validation tasks, which is indicated by the dashed line in Figure 6. The third step is forecasting with input data from Vietnam by each model. After fitting the models, we got results as presented in Figures 7 to 9 in Table 3. Figures 7 to 9 illustrate the MSE on training, loss, the blue line, and MSE on validating, val loss, the yellow line, of each epoch from the models on each country data. The loss and val loss values are descending to 0 and keep stabling after a number of epochs. It means that the models are in good fitting conditions. Table 3 shows the MSE of the models trained by COVID-19 data from the regional nations of Vietnam. It can be inferred from Table 3 that MSE of GRU is the smallest error of the models. The hybrid models always give better MSE than LSTM does. Therefore, the LSTM model performs worst when comparing these models.
We used 15 last normalized data steps of Vietnam's column as input data, to forecast the number of new cases of COVID-19 in the next 15 days. The predicted values are transformed to the observed scale. The results are plotted as in Figure 10 to 12. They demonstrate the 3 likely scenarios of COVID-19 in Vietnam, since these predictions were made by the training data collected from the Philippines, Malaysia, Thailand, and validated by data from Vietnam. Overall, an upward trend was foreseen in Malaysia's and Thailand's models, whereas the Philippines one provided an opposite tendency.
Figure 10 illustrates the situation of COVID-19 in Vietnam, which was forecasted by the models trained on the Philippines data. In general, it is a downward trend. The number of new infections in Vietnam will reach the peak at over 9,500 cases on August 4, then fluctuate and go down to 7,500 on August 15.
Figure 11 demonstrates the circumstance of COVID-19 in Vietnam, which was predicted by the models trained on Malaysia's data. We can see the contrast of Figure 11 with Figure 10. This time, the new COVID-19 cases in Vietnam are going up. It could escalate from 7,500 to 11,000 patients, as noted on August 1 and August 15, respectively.
The forecasting of COVID-19 in Vietnam as mentioned in Figure 12 is similar to Figure 11. It was created by the models trained on Thailand's data. It shows that Vietnam's situation could go worse due to a sharp increase of the COVID-19 new cases, about 6,000 to 20,000 new infections from August 1 to August 15.
This research is funded by the University of Economics Ho Chi Minh City, Vietnam, UEH. The authors wish to extend our special thanks to Johns Hopkins University Lab, where we received raw data. We also would like to thank Mrs. Nguyen Tran Min Chow from UEH Library. Mrs. Nguyen Lee Kiu Chin from the campus in Vinh Long of UEH helped us finalize this study.